Hello dear students, myself Mohammad Wasim, Assistant Professor in Mathematics, Art Science, Commerce College, Badnapur. Today we are going to start with new example in inverse Laplace transform. Inverse Laplace transform. Inverse Laplace transform. In which we are studying about inverse Laplace transform, in which we have started some examples. Now today we will see some special type of examples which are based on shifting theorem. So find the inverse Laplace transform of a e raised to minus as upon s square plus 1, b e raised to minus pi s square plus 1, c e raised to minus 3s upon s minus 4 square, d e raised to minus 5s s plus 2 bracket is to 4. It is dependent on shifting theorem, and we will use Heaviside function to find or to convert in exact solution of these examples. Let us start with the first example, where find the inverse Laplace transform. Means we have to calculate inverse Laplace transform of e raised to minus s square plus 1, and we can find it by using or indicating first part, that is 1 upon x square plus 1 as f of s. We can easily find inverse Laplace transform of this f of s. Inverse Laplace transform of 1 upon s square plus 1, and which is equals to sine p. Since we know that inverse Laplace transform of a upon s square plus a square is equals to, or 1 upon s square plus a square becomes 1 upon a sine a t. By using this formula, we have calculated the inverse Laplace transform of 1 upon s square plus 1, or 1 square. Now it is our required result of inverse Laplace of f of s. Now we will see, after applying inverse Laplace transform to e raised to minus as upon s square plus 1 will use us, since we know that inverse Laplace transform of e raised to fs minus t, since we know that inverse Laplace transform of e raised to minus as f of s will use us f of t minus a h of t minus t. We know that this formula inverse Laplace transform of e raised to a as f of s is equals to f of t minus a into h t minus a, where h of t minus a is equals to 1 whenever t is greater than a and 0 whenever t is less than a. So, by using this formula, we can solve this, since inverse Laplace transform of e raised to minus as into 1 upon s square plus 1 will give us f of t minus a, and we have calculated f of t as sin t. So we can write it as sin t minus a h of t minus a, and it is the required solution for our example. Or we can write it as also sin t minus a h of t minus a whenever t is greater than a, 0 whenever t is less than a, and it is the required result for this example. Now we can find the second example easily by using shifting theorem. Now second example is as follows. E raised to minus pi s e raised to minus pi s inverse Laplace transform of e raised to minus pi s upon s square plus 1. We have to find inverse Laplace transform of this function. Here we have f of s is equals to s square 1 upon s square plus 1. So taking inverse Laplace transform of this, we have to take inverse Laplace transform of f of s, and we will get inverse Laplace transform of 1 upon s square plus 1 as sin t by using the formula of inverse Laplace transform of 1 upon s square plus a square, which will give us 1 upon a sin a t. Now we have f of t here. Now we have to calculate inverse Laplace transform of e raised to minus pi s upon s square plus 1, and since we know that by using Heaviside function we can write it as inverse Laplace transform of e raised to minus as f of s will give us f of t minus a h of t minus a, where h of t minus a is equals to 1 and 0 whenever t is greater than a and whenever t is less than a. So putting this value in this formula, we will get inverse Laplace transform of e raised to minus pi s. F of s means 1 upon s square plus 1, and we know f of t. F of t is sin t, so we can write it as sin t minus pi h of t minus pi. Correct? And it is the required result for our second example. What we have done here, we have just find f of t by using inverse Laplace transform to f of s, which is given in the example. Applying inverse Laplace transform to 1 upon s square plus 1, we will get sin t, which is equals to f of t, applying Heaviside function and first shifting theorem to this particular example, we will get the result. Now, for next example, example number third C, and which is given as find the inverse Laplace transform of e raised to minus 3s s minus 4 square. We have to calculate inverse Laplace transform of this term. Now here we can substitute f of s is equals to 1 upon s minus 4 square. Now taking inverse Laplace transform of this f of s, we will get inverse Laplace transform of 1 upon s minus 4 square. Now by using first shifting theorem, we can write it as e raised to plus 4t inverse Laplace transform of 1 upon s square, and which is e raised to 4t t raised to 1 factorial. So it will use us t into e raised to 4t. Correct? Now we have f of t. Now directly we can apply shifting theorem by using e raised to minus 3s. Since we know that inverse Laplace transform of e raised to minus as f of s will give us f of t minus a h of t minus a, and similarly we can apply inverse Laplace transform to e raised to minus 3s and f of s, that is 1 upon s minus 4 square. So we can apply to this f of t minus a means t minus 3 e raised to 4 t minus 3 h of t minus 3, which will use us t minus 3 e raised to 4t minus 12 h of t minus 3, and which is equals to t minus 3 e raised to 4t minus 12 h of t minus 3 whenever t is greater than 3 and 0 when t is less than 3. It is the required result for our third example. And similarly, we can use or solve easily our fourth example and last example. That is inverse Laplace transform of e raised to minus 5s upon s plus 2 raised to 4, and here f of s, consider f of s is equals to 1 upon s plus 2 raised to 4. Taking inverse Laplace transform to both sides, we will get inverse Laplace transform of f of s, inverse Laplace transform of s plus 2 raised to 4, and we will get e raised to minus 2t inverse Laplace transform of 1 upon s raised to 4, and which is equals to e raised to minus 2t, which is equals to t cube upon 3 factorial, which is equals to e raised to minus 2t t cube upon 6. Correct? Now, by using the formula inverse Laplace transform of e raised to minus a f of s is equals to f of t minus a h of t minus a, where h of t minus a is Heaviside function, which is equals to 1 whenever t is greater than a, and h of t is equals to 0 whenever t is less than a. So applying to our example, we will get e raised to minus 5s upon s plus 2 raised to 4. We will see by using this term e raised to minus 2 t minus 5 upon 6 into t minus 5 raised to 3 h of t minus 5, and it will use us e raised to minus 2t plus 10 and t minus 5 keep it as it is h of t minus 5 whenever t is equals to 1 and equals to 0 whenever t is less than 2. And this is our required result for such type of example. Now, in this example, we have seen that a power exponential function is in numerator and a function is given in denominator. Can be easily find the inverse Laplace transform of that function, and applying this formula, inverse Laplace transform of e raised to as f of s is equal to f of t minus a h of t minus a. Now, one more example from same type of problems. Find the inverse Laplace transform of e raised to inverse Laplace transform of s plus 1 e raised to minus 5s upon s square plus s plus 1, and we can find the result for this function. Consider f of s is equals to s plus 1 s square plus s plus 1. Now we can solve this example by using two different methods. First one is by using partial fraction and by using direct method by doing square in denominator and substituting to s plus 1 or find the square of this denominator and convert numerator as per our need in denominator to apply first shifting theorem. So let's see first that method. We can use s square plus s plus 1 by 2 or 1 by 4. Let's see. Now try to make it s square plus s plus 1. Whenever we apply s plus 1 by 2 square, we will get s square plus 2 into s into 1 by 2, and 1 by 2 square means we will cancel, we get s square plus s 1 by 4. Correct? So we can write it as 1 by 4 plus 3 by 4 and s plus 1 by 2 plus 1 by 2. Now we can easily simplify to this expression. We will get s plus 1 by 2 plus 1 by 2 upon s plus 1 by 2 bracket square plus root 3 by 2 square. Correct? Now applying inverse Laplace transform to this, s plus 1 by 2 plus 1 by 2 upon s plus 1 by 2 bracket square plus root 3 by 4 bracket square, and which will gives us e raised to minus 2t by e raised to minus 1 by 2t inverse Laplace transform of s plus 1 by 2, and it becomes s square plus root 3 by 4 bracket square. Correct? Now we can easily distribute this denominator to x in 1 by 2 also. So we will get e raised to minus 1 by 2t inverse Laplace transform of s upon s square plus root 3 by 4 square plus 1 by root inverse Laplace transform of 1 upon s square plus root 3 by 4 bracket square. Now it becomes e raised to minus 1 by 2t. It becomes cos root 3 by 4 t plus 1 by 2 into 1 by root 3 by 4 sine root 3 by 4 t, and it is our required result after solving inverse Laplace transform of function s plus 1 upon s square plus s plus 1. Now, since we have to calculate inverse Laplace transform of e raised to minus 5s upon by s into s plus 1 upon s square plus s plus 1 by using formula inverse Laplace transform of e raised to minus es f of s, which will use us f of t minus a h of t minus a. Correct? So we can use here e raised to minus 1 by 2 t minus 5 cos root 3 by 4 t minus 5 plus 1 by 2, or we can say 1 by root 3 sine root 3 by 4 t minus 5, and it is the required answer for this example. It is somewhat lengthy, but it uses very basic theorems from our inverse Laplace transform chapter. So it is example which contain e raised to something in numerator. So we can use this formula to solve such type of example. So remember and try to do it yourself, all the example. You will be very beneficial in your exam when such type of example occur in your exam. So please keep studying and keep practicing. Till then, thank you. Bye.